Okay, so in this video we're going to see the different parts of a bone, the structure of a bone using a specimen, a cow specimen. Okay, so this bone, it's a long bone. Remember, long bones are the ones that are kind of longer than wider, or taller than wider. Okay, and in the bones we have long bones. We have different parts, the endings, which are known as epiphyses, and the mid part, which is known as diaphysis or shaft. And the part in between the epiphyses, the endings, and the diaphysis is called metaphysis, which is this part. Okay, so this is the epiphysis, metaphysis, diaphysis, and then metaphysis in here, and then diaphysis again. Sorry, metaphysis and epiphysis in here. Now, this is a longitudinal section, so when you're looking at a bone, you can see the external surface, and in order for us to see the internal surface, you have to make a cut, a longitudinal or sagittal cut. So in the sagittal cut, what you can see is the different layers of the bone. The outer layer, which is this is the periosteum. It's a membrane that covers the bones. And then in this part that you can see here in the diaphysis, you see the compact bone, which is very solid. It's called compact because the cells that make up the bone, which are the osteocytes, are close together. So that's why it's compact, and you can hear the sound of compact bone. Now in here internally in the diaphysis, you have a cavity. This is the bone marrow. Depending on the age of the animal or the person is what you will find within the marrow. If it's an adult bone, you will see fat. And fat is yellow or whitish in color. So this one, it's a specimen from an adult animal. And then if it's a young animal or a young person, you will see a red marrow. And it's red marrow because in here, in the diaphysis of young animals or young persons, you have production of red blood cells. So you have erythropoiesis together with other cells. The bone marrow in general produces, in young animals or young persons, produces blood cells, whether are white blood cells or red blood cells. And in the epiphyses of long bones or the actual tissue of short bones, you will find this type of tissue, which is a spongy bone. And in a spongy bone, no matter if it's a short bone or a long bone, you always produce red blood cells. So it will be basically not red marrow because it's not classified as red marrow, but you always have erythropoiesis or hematopoiesis for production of red blood cells and white blood cells. So a spongy bone, it is made of osteocytes as well, the cells of the bone, but the osteocytes are scattered, so they are more farther apart. That's why it's spongy. So this tissue is more fragile, the spongy bone, than the compact bone. And if you listen to, the sound is less loud than compact bone. And then we have this membrane within the diaphysis that it is the endosteum. Now we have osteocytes within the periosteal layer and the endosteal layer of the bone. And then we have not only osteocytes, but we also have osteoclasts. The osteoclasts will be cells that break bone or dissolve bone, while the osteocytes deposit bone. And we have it at different ratios. So we have osteoclasts and osteoblasts or osteocytes within the periosteum and within the endosteum. Now, when I mention osteoblast, osteoblast is the precursor of the osteocyte. So it's the most immature form of an osteocyte. Whenever you listen to the blast prefix in words, or suffix actually in words, that means blast is immature cell. So you might hear hemocytoblast, which is an immature cell that produces blood cells. So in the case of the osteoblasts are the most immature form, so basically are the stem cell, and then they convert into osteocytes, which is a mature form that actually deposits calcium within the bones. The bones are made of calcium salts, and then the osteocytes then deposit the calcium, while the osteoclasts chew up the calcium from our bones, so it makes it more porous. So we have then different ratios of osteocytes to osteoclasts in the periosteum in comparison to the number that we have here in the bone marrow. So in the bone marrow, we have more osteoclasts than osteocytes or osteoblasts. And then in the periosteum, we have more osteocytes or osteoblasts than osteoclasts. So what it means is that we have more deposition of bone within the periosteum than in the endosteum. So as we deposit bone to make the bones to grow in diameter, we put it more in the outside than in the inside. Because if we put more bone in the inside, what is going to happen is that we will close the marrow, and we don't want that. So we want to maintain a specific diameter within the marrow so we don't occlude the marrow. And that's why we have more osteoclasts. So we have more reabsorption of bone within the osteoclast than, within the endosteum than in the periosteum. Okay, and then then we have here the bone marrow. Now, when we grow our bones, as we are young, we grow them in length. So we have here a pad of cartilage. And actually our bones during fetal development are made out of cartilage. Will be hyaline cartilage. Remember, we have 3 types of cartilage, and one of it will be hyaline cartilage. Hyaline cartilage basically makes the model. And then as the bone, and as the bone is ossifying or having deposits of calcium, that cartilage, the hyaline cartilage, is replaced by bone. Now, when a young animal or a young person is growing, it will have within the metaphyses a pad of cartilage. And this will be called the epiphyseal plate. And as we finish the growth in length, this epiphyseal plate gets replaced with calcium, and then eventually it will lead to the formation of a line. That is going to be called the epiphyseal line. And the bones in our body, they have different rates of growing. They stop growing at a different age. So we can calculate the age of a person just by looking at x-rays, in most of the cases by looking at thickness of this epiphyseal plate. At some point, the thickness of the epiphyseal plate has been measured in most of our bones in our body, and they can calculate the age of the person. And this is important, for instance, when there is forensic investigations going on. So let's say that you find just the bone of a person, they can take the x-rays, and then they can measure the thickness of the epiphyseal plate and then give an approximate time for the age of the person. Approximate age. Okay, so that's the parts of the bone that you can see. And here we have then this periosteal layer that helps to prevent the fusion of the muscle, which is part of this is dry muscle, the fusion of the muscle and merging of the muscle with the tissue of the bone. Within the diaphysis and within the epiphysis, we have foramina or holes. These foramina or holes are called nutrient foramina. And we have usually many nutrient foramina that provides blood supply to the osteocytes within the diaphysis, and also many within the epiphysis. And at least in here, in this part, where I'm going to stick the tip of the probe, you can see these nutrient foramina in there. When we age, especially the one in the head of the femur, which in this case it will be this, when we age, the nutrient foramina that provides blood supply to the head of the femur can get occluded. So when you don't have enough blood supply going into the head of the femur, this bone becomes really weak. And a little bit of physical trauma into this area can lead to the breaking of the neck of the femur. So that's what happens then when someone has a broken hip. The neck of the femur breaks, which is this part, and then the nutrient foramina that goes into the head, into the neck, get occluded for some reason, usually because of a plaque, and then the osteocytes undergo necrosis, and this bone becomes really weak. Now, in long bones in the limbs, we have this articular cartilage, which is also made out of hyaline cartilage. The articular cartilage is very important because it prevents direct friction of bone to other bone. When someone has direct friction of bone to bone, because this pad of cartilage has thinned out, the person will have wear of the articulation, like what happened in rheumatoid arthritis. So they have inflammatory process going on. This articular cartilage, which you cannot listen because this is cartilage, is less denser than compact bone. See how compact bone, you can hear it, and then in here you don't hear as much because it's a cushion to prevent friction. So when this wears out, like in rheumatoid arthritis, you have a shortening and deformation of the articulation, especially the ones in the fingers. So that's what you can have. Also, you can have bursae, which are basically little pouches with synovial fluid to prevent this friction. And then you can have some fat, like you can see in here. Okay, so, and menisci. So this is actually a meniscus in the femur of this specimen. So this is then the different parts of the bone, the long bone, and I will see you in the next video. Bye-bye.